Greetings and welcome back to Physics with Captain Rod. I'm making this video here to help you out with your homework here. We're going to be looking at homework Unit 1-1 here. And by the way, in my little convention here, it's the Unit 1 homework, and it's the first of set of homework in Unit 1. We're going to talk about numbers 3, 4, and 5. So as I look at number 3 here, let's see. It says a graph below plots the position of a particle. And I did just a super rough sketch of that graph. It looks, you should be looking at something just very similar to this. I'm not going to bother filling in all the details here, as this homework is just to get you, or this video is just to get you started on your homework. And it says to calculate average velocity over the following time intervals. So the first thing I like to do is, write out that velocity is equal to delta x over delta t. Now that's how average velocity is calculated. And an important thing to realize, change in x over change in t. This is a slope of an x against t graph, which is what we're looking at over here on the left. So really what they're asking us for is the slope of this graph. So it says, part A says from 0 to 2 seconds. So that's the slope of the line between 0, 0 and 0, 2. So basically you're just asked to calculate the slope of this line. Now, part B says from 0 to 4 seconds. So let me write that one down here. So part B, 0 to 4 seconds. So 0, 0 on the graph, again, is here. And then when t is 4, and I'm reading this right off the picture, it looks like x is 4. That's here. So what you're actually getting is the slope of this line. You're going to use this for your rise, this for your run. And although you might be wondering, well, this doesn't lie on the graph just like the other one does, that doesn't matter. Chat about that a little bit. Remember that velocity is a slope on this graph. And during the first part of the trip here, the slope is pretty steep. And it's positive. And during the second part of this trip, the slope also relatively steep, and it's negative. This slope represents an average for the entire time interval. All right, let's see, when it says from 2 to 4 seconds. So I'm going to put this in blue. When t is 0, we're here on the graph. And when t is, what was I doing from part C, from 2 to 4? When t is 4 seconds, we're here on the graph. So that's the slope you're going to be finding there in part C. And part D says from 4 to 7. Well, use a different color here. On our graph here, let's see, when t is 4 seconds, we are here. And when t is 7 seconds, looks like we are here. So you're going to be finding the slope of this line. Okay, and I'm just going to say and so forth for the rest of it. That should get you rolling on that problem. All right, let's talk about the next one here. All right, it's a very similar question. I'm just going to do a quick sketch of what I'm looking at. You should be seeing a graph that looks roughly like this. Good enough. And again, this is a position graph. This is x measured in meters against t measured in seconds. And let's read the directions here. What is the test player's average velocity over the given time interval? So this is similar to the other one, to the other question. Now, average velocity is equal to delta x over delta t. You should write that down. And then recognize this is a slope of this position graph. So from 0 to 1, right, when t is 0, we're here on the graph. When t is 1, we're here on the graph. So it's the slope of this line that we're talking about. Part B, from 0 to 4. Well, when t is 0, and I'm going to do this with a different color, green, or I guess red. We're here on the graph, and when t is 4 seconds, looks like we are here on the graph, so you're looking for the slope of this line. And I'm just going to say and so forth for the rest of this. That should get you rolling on that. Let's talk about the next one. Problem number 5. Give me a moment to sketch this. So when you pull this up, you should be seeing a graph that looks roughly like this, super roughly. This is now a velocity graph measured in meter per second against time measured in seconds. So for this graph, or for this problem, let's see. Question A, what is the average acceleration during the following time intervals? So start by writing out, how is acceleration calculated? Well, average acceleration is change in velocity over change in time. Hopefully now when you look at this formula, that will help you recognize that this is slope of velocity against time. Just like in an algebra class, you know how slope, usually it's written with the letter M, is delta y over delta x, right? So slope is a change in a rise, in this case typically y over, whoops, and I wrote t, I meant x there, against x. Well, acceleration this is going to be a rise, your delta v. This is your run, a delta t. So acceleration is the slope of a velocity against time graph. Now, part A says from 0 to 6 seconds. So when t is 0, we are here on the graph. When t is 6, looks to me like we are about here. So you're looking at the slope of this line, and I don't want to give that away. You can calculate, or hopefully you know what that is by looking at it. Part B, let me do this one in red. It says from 6 to 18. So at t equals 6, we are here on the graph. At t equals 18, we are up here. You're going to be calculating the slope of that line. And third part, from 0 to 24. So let me do this one in blue. When t is 0, we're here on the graph. When t is 24, we're here on the graph. So the slope, that's going to be the slope of this line. Now, the second part here, where it says what are the instantaneous accelerations. So the first one says at 1 second. So at 1 second on the graph, we're here somewhere. So the answer to that question is the slope at this point. But this is straight in this region. So really the slope is the same everywhere along here. That should be enough to get that answered. When t is 12 seconds, we are here on the graph. And again, you'll notice this is straight. You should be able to pick any 2 points on this line to get the slope, and that will tell you the slope at that point. And that's probably enough on that particular problem. So I'm going to just end that video right here and call that enough for this. I hope that this helps you get your homework done, and we'll have a great day.